When we are asked about light, we often have to draw ray diagrams. But what's a ray? A light ray is a narrow beam of light, and we also know that light travels in straight lines. So when we're drawing light diagrams or ray diagrams, we must always use a pencil and a ruler. The use of a pencil allows for easy correction in the case of a mistake or an error, and you must use a ruler because light itself travels in straight lines. What you're drawing is a ray to represent the light, therefore it must be a straight line. So you must use a ruler. And you must always put an arrow on the ray. Light travels in a certain direction, and you must put an arrow on the ray to indicate the direction of travel of the light. And unless you have both elements ticked there, the pencil and ruler, and the arrow on the ray, then you are likely to lose marks in the exam. And what a silly way to throw away marks. An application then in terms of rays of light and shadows and so on is the use of a pinhole camera. Pinhole camera is basically a box with a narrow slit at one end and a wider gap cut out of the far end that is then covered in a semi-transparent material. So a translucent material to form a screen. Here we have an object from which rays of light will come, and remembering that whenever we see an object, it's because the rays of light have travelled straight to our eyes from the object. We can draw the rays of light from the top of the object and also from the bottom of the object as they pass into the pinhole camera. So from the top of the object, only the rays that are travelling through the hole will manage to get to the screen. And from the bottom of the object again, only the rays of light that actually travel through that hole or gap will manage to get to the screen. And we remember we always draw the straight lines and put an arrow on it to indicate the direction of the ray of light. Now, this ray of light coming from the top of the object, passing through the hole, is now at the bottom of the screen. And the ray of light travelling from the bottom of the object through the pinhole is now at the top of the screen. So we can now actually draw the image that we would see on the screen. And it's inverted. And by inverted, we mean that it's upside down. When we examine the image, we find that not only is it inverted, but it's also smaller than the object, and it can be indistinct, largely due to the size of the pinhole that you have. So that's what affects that.